Hello everyone. So in the previous videos we had completed minimum mode interface. Now let us begin with the maximum mode interface. So in the maximum mode interface, we can use coprocessors together. So when the 8086 is set for the maximum mode configuration, it provides signals for implementing a multiprocessor coprocessor system environment. By multiprocessor environment, we mean that one microprocessor exists in the system and that each processor is executing its own program. Usually, in this type of system environment, there are some system resources that are common to all processors. They are called as global resources. There are also other resources that are assigned to specific processors. These are known as local or private resources. तो ये जो पीपीटी स्लाइड है यहाँ पे इन्होंने ये बताया है कि अगर हमें इसे को प्रोसेसर मोड में चलाना है जैसे 8086 जो है ये खुद एक माइक्रो प्रोसेसर है बट इसके साथ बाजू में एक और प्रोसेसर एग्जिस्ट कर सकता है और इसे हम को प्रोसेसर बोलते हैं जैसे 8087 जो है वो मैथ को प्रोसेसर है तो जो भी मैथमेटिकल ऑपरेशंस है 8086 के वो 8087 करेगा को प्रोसेसर मोड। तो इसमें ऐसा होता है कि ऐसा नहीं है कि पूरे के पूरे सिस्टम ही अलग है तो फिर तो वो अलग अलग प्रोसेसर्स ही हो जाएंगे। यहाँ पे ऐसा होता है कि कुछ रिसोर्सेज कॉमन होंगे और कुछ रिसोर्सेज प्राइवेट होंगे। तो ऑब्वियसली जो रिसोर्सेज कॉमन है उसे हम बोलेंगे ग्लोबल रिसोर्सेज और जो रिसोर्सेज प्राइवेट है उसे हम बोलेंगे प्राइवेट रिसोर्सेज। अभी इसमें इम्पोर्टेंट ये है कि हम वो डिस्टिंग्विश कैसे करते हैं या बेसिकली उसे असेंबल कैसे करते हैं 8086 माइक्रो प्रोसेसर को मैक्सिमम मोड में लेके आना तो कोई बड़ी बात नहीं है क्योंकि एक मिनिमम मैक्सिमम का पिन ही है जिसको जीरो पे रखेंगे तो वो मैक्सिमम मोड पे चला जाएगा। बट जैसे ही वो मैक्सिमम मोड पे जाता है तब उसका फंक्शनिंग कैसा होता है ये हमें देखना है। सो मूविंग ऑन। Okay, so I guess I've already explained you this slide in the previous one only. Just going through it, one passes the control of the system bus to the other and then may suspend its operation. So that is what they are saying in this particular slide that whenever they are coexisting, it doesn't mean both of them are using the resources at the same time. One processor will be using it and then once the work is complete, so it will then pass the control of the system to the other and then suspend its own operation. So let's see the diagram for the 8086 maximum mode. So as we can see, this is the 8086 microprocessor and we already know the working of few signals from here. So when the minimum slash maximum bar is set to 0 because it is grounded, so the maximum mode is activated. We already know about all these interrupts like test bar, NMI, reset, INTR, and here there are some other blocks. So one is a bus controller and the other is the bus arbiter. So let us have a look at it in detail. Now, the bus controller is having this three pins connected to it S0, S1, and S2. Same bus arbiter is also having those pins connected to S0, S1, and S2 bar of this block. As we can see, there is a clock. It is connected to the clock of microprocessor. There is AEN bar, which is connected to AEN bar of the microprocessor. There is IOB bar, and there are all these different signals. So what we can do is we'll go on to the next slide and we'll understand all these pins and we'll come back and we'll compare this diagram with the same. So the first thing we are going to talk about is the bus controller. So this is the 8288 bus controller. It is going to control the buses as the name suggests. 8086 does not directly provide all the signals that are required to control the memory, IO, and interrupt interfaces. Especially the write bar, M/IO bar, DT/R bar, TEN bar, ALE bar, and INTA signals are no longer produced by the 8086. Instead, it outputs three status signals S0, S1, S2 prior to the initiation of each bus cycle. This 3-bit bus status code identifies which type of bus cycle is to follow. S2 bar, S1 bar, S0 bar are input to the external bus controller device. The bus controller generates the appropriately timed command and control signals. So now what they are saying is, now all these pins are no longer controlled by 8086. Like before in the minimum mode, all these pins like read bar, write bar, DEN bar, ALE bar, INTA bar, all these pins were controlled by the microprocessor itself. In the maximum mode, it is controlled by the 8288 bus controller. So how does microprocessor send command to this with the help of these three status pins S2 bar, S1 bar, and S0 bar. So it is the input to the 8288 bus controller, and these are the various outputs. Now, so these are the various status, and then we'll come to know exactly what is the command for 8288. So if all the three pins are 0, the command is INTA bar. So if the microprocessor wants to send an interrupt acknowledgement 8086 microprocessor, it will put all these pins to 0. So by default an INTA bar signal is given out of the bus control. So indirectly 8086 is only controlling it, but it has reduced its work by hiring an assistant, we can say. So sending 000 will make the 8288 bus controller release a INTA bar signal. Same way 001 is IORC, that means IO read control. Okay, so 001 is IO read control, 010 is IO write control, 011 is halt, and so on. So there is IO read, there is IO write, there is memory read, there is memory write, and there is none, and there is halt and passive. So these are the various codes, and these are the various commands for the 8288 bus controller. Now the 8288 produces one or two of these 8 command signals for each bus cycle. For instance, when the output of 8086, the code is 001, it indicates that a IO read cycle is to be performed. We've already discussed this. Okay. The control outputs produced by the 8288 are DEN, DT/R bar, and ALE. These three signals provide the same functions as those described in the minimum system mode. This set of bus commands and control signals is compatible with the multibus and industry standard for interfacing microprocessor systems. So that is all about 8288, if we can see. So using these three pins, these are the various outputs which we are going to get. And along with that, there are three control pins with the 8288 bus controller. We have already seen this DEN, DT/R bar, and ALE operations. So they are going to do the same operations. Only difference is now it is controlled by 8288 and not 8086. So all these things are still indirectly controlled by 8086, but this is not at all controlled by 8086. Moving on. The next is the 8289 bus arbitration and log signals. So let us do this in the next video. Thank you.